You're listening to CB radio being picked up by this. Skipping from the southern states, skipping up here. So hello, welcome to my shop, and thank you for joining me here today. I wanted to right away demonstrate that this radio is actually working. Maybe not perfectly, but much better than I had expected. And so you were listening to CB radio. That's at 27 megahertz. And I was listening to CB last night on a regular radio. CB radio, which I get a kick out of listening to it. I like to check in and see what's going on. Is there any skip happening? It's just something I do. I have a whip, a 102 centimeter whip antenna out connected to the CB radio, so it works fairly well. And I was listening to it last night, and I suddenly realized, oh my gosh, maybe this radio can do it. So I ran down here, turned it on, and sure enough, this radio can pick it up. I like opium? Is that what he said? Anyway, you can listen to this all you like on your own radios. But when I was a kid, for Christmas, and it would have been maybe when I was 7 or 8 years old, my parents relented and bought me a pair of walkie-talkies. And of course, it's just me in the house. I have 2 sisters with no brothers, so what am I going to do with walkie-talkies? But anyway, there it was, Sunday afternoon. I turned it on, my walkie-talkie, and what do I hear coming out of it? This stuff. Exactly the way it is still today. I was freaked out by that. What is this? Strange stuff coming out on this radio. Yeah, and maybe that's why I'm so fascinated by it even today, because as a child I found it really quite almost shocking in a way. This thing has a noise control system we can experiment with right now. A muting control. There's an adjustment on the back. And the idea is it's supposed to mute out the hiss. And then, just like a squelch. In fact, maybe this is an early squelch, but no. It never lets the signal through. So the thing is, that's full volume. It's not bad, but you should be getting that kind of volume way down here. So I think there's still clear evidence of weakness, and as distorted as CB stuff always is, I think there's additional distortion here. So I think I'm still fighting weakness and distortion, even though the radio's working much better than I had realized. Great, so what are we going to do today? Yesterday I did what I think is an okay alignment on the FM side of things, and I really thought that was going to clear up the distortion, and I was kind of hoping the distortion is just in the FM signal. I put 25 cents down that said, hey, do that alignment, distortion gone, but it didn't have any impact at all. So the radio remains distorted. My quarter's still here, and my cat is just freaking out over a stick. Here, I'll get it. Here. You like a stick, eh? Oh, come on. Keep your stick up here now. So what to do today? Good question. Okay, here's the weather report for today. Rain all day, high of 9. That was the weather report. So we've had days of rain here, and it looks like we're going to have a couple more days of just rain, non-stop rain. And it's cold. It's much colder than it should be. Okay, enough of the weather report. That didn't help. I still don't know what to do with this next. Maybe what I should do is I should look at the tubes that are related to the detection of the signal, where that's where some of this distortion could be coming, and check them again. Put them through the tube tester. That's not impossible. That's not risky. That's really what I want to say. What's laying in front of me here is starting to change components, capacitors in particular, and it does not look like a friendly job at all. It looks like a horrifying job. So that's why I'm not in here changing capacitors one after another. Uh-oh. Look what's happened here. Number 2 is showing up. Hey, there's a stick happening. What's going on here? Yesterday's stick went well. I don't know where it ended up, but somewhere in our house now. I don't know. Just waiting for that. So yeah, I think maybe that's what I'll do. We'll look here. Can you get off this, please? And here, this is a list of tubes that identifies their function. So all I can do is just go in and pick off like a FM discriminator tube, 6AL5, and pull it out. You can see I replaced it. Can you see this? No. So these are the ones I replaced already. And we're going to do another one. This is the shorted, damaged in the radio question mark FM discriminator tube. This is the one that had the short in it. Okay, that sounds like the only thing I think I do is turn this off. And what are you doing over here? Oh my God! It's under attack. It's a cat attack. That's my grandparents up there in that picture. Okay, busy cats. They're more busy than I am. I found the only way to light this so you can see the pointer is to use this very reduced lighting. So I think I have this set up for a 6AL5. Let's just double check. 6AL5. So it's a diode, so we don't have to set this or set the bias. These switches are K3761. K3761. 2P00. 2P00. 39. And plate voltage A. Good to go. There we go. So this particular tube is a replacement tube that came from my my tube collection. And I would have tested it. I don't remember now, but I would have tested it to ensure it's working before putting it in the radio. Well, let's try it out. Okay, so the first test is leakage test or internal short test, and it's reflected by the meter. The meter should not move when I do this test. There we are. Okay, showing up just fine. Test for a diode or a rectifier is this switch here. And it has more instructions. P1, K1, P2, K2. So it's a two-part tube, and they're quite separate inside. So I have to throw some switches to test this side or that side. So first side, this switch. So there's a little bit here you probably can't read. It says diode's okay as long as it's above where my finger is, and it's above. So diode, then we go K2, P2, and we do it again. This is testing just normal. This is a normal response for a 6AL5. Nothing wrong with this tube. Okay, I'm going to pop it back in. We'll get the other 6AL5 out here. It's really dark in here. You know, the camera compensates a lot, and here's the other 6AL5 is V10. This is the V10 noise limiter and EGC. Well, I don't see how this has any bearing on the problems we're having, but since the tube tester is set up for 6AL5, let's do it. And we can leave these switches down, just do things in reverse. Oops, give it a moment to warm up. Okay, that sounds like a moment. I just got an email from Darren. Okay, and here we go, test. It's higher than the last one. They're both testing fine. This is testing a little better than the other tube, but I think it would not have any impact. Certainly not the problems that I'm trying to resolve. So is there anything else? There's some more stuff in here. We have, those are the two 6AL5s. So we have a limiter V8 6AU6. Well, let's try that one next. According to my test, it was okay, but we'll just test. We need to test all these again, just to be sure. Okay, next tube, 6AU6. Yep, 6AU6. FM limiter, I believe, is what this one was. So double checking now. 6.3 volts, signal level 4. 9L on the bias, 52763, 52763, 4100, 4100, 45, C. Let's go. Now there's a number of 6AU6s. I might as well test them all once I have the tester set up. Kind of makes sense to do them all. But this one is involved in the FM circuitry. And I think I've commented a number of times the FM does not seem to be limited, but I think it's from insufficient signal, not from a problem with the limiter tube. So we have an FM, we have a noise limiter, S meter, beat frequency, noise, amplifier, muting, push-pull. So the limiter, FM discriminator, we did that. And noise limiter and AGC, we did that. Those are the two 6AL5s. The only other one that's FM oriented according to this list is this one. V8. Is this V8? Yeah, I think it's V8. Yes. I had a V8. My father bought a new car, gave me his old one. It was a 1969 Buick Skylark with a 350 cubic inch engine in it, and way too powerful for a 16-year-old to go out bombing around in. Lucky I didn't kill myself. Actually, I've always been a fairly safe driver, so other than making mistakes, I was never reckless as a driver. Okay, we're ready. Here we go. My friends were reckless. That's for sure. Here we go. This will pass the test if it's above 1300. 1300 is where you want to replace the tube. Oh! Really? Really? Wait a minute. Hold on a second here. Hold on a second here. That I'm surprised because I tested this tube previously. 52763. 52763. If this tube is this tube is bad, that's a good news. 4100. 45 on the sensitivity for the meter. C for the plate voltage. 1300 is the reject point. Have I really got the right thing? 686. Yeah, absolutely. Give it another go. She's a dud. Oh my gosh, I'm really excited. Okay. Now this would only affect the FM side of things, but that's where the distortion seems to be. Okay, very excited. Shame on me. How did I miss this? How did I miss this? So this is the FM limiter. So I wrote down 1400. Well, that's no 1400. Maybe I made a mistake when I first tested it. Well, let's get rid of this and try this radio again. Yeah, I kind of find myself a new 6AU6. I'll just give you a peek at how I store some tubes. I have a complex tube storage system. There's a couple of different ways tubes get stored. So I keep an index, and in my index is a column that shows where the tube is. So in this particular case, this box is full of tubes that start with 6A. 6A this and 6A that. Somewhere in here will be 6AU6s. And I have to look through them. I have to look through. I've written the name. Each bag carries a certain type, and I've written the name on it. And I imagine we're going to find a bag of 6A6s in here. 6A, and I got this roughly in order. Roughly, very roughly. Very roughly. Uh-oh. Hey, here we are. 6AU6. I've got a few. Okay, these have all been tested, but only in proof that they operate, that the heaters heat, and not much more than that. And it shows up on the meter to some degree. I need to just... Another thing I do is, this is the bad one that's come out of the radio, and what I've done is I bent one pin over a little bit, just to mark it. Because no matter how hard I try, these things shuffle around here in my shop, and you know, I don't know what I'm doing. I don't know what I've got. Okay, so we're going to double check and make sure it's a... Oh, I can see it from here. 6AU6. There's a 6AU6 and a 6AU6A. The A heats up at a very controlled rate. In some cases, I guess, in some radios or equipment, you want things to heat up in a certain order. And I guess. So the rate at which this one heats up is controlled differently than the 6AU6. This is just a 6AU6 here. Okay, in the midst of my cats sneaking around in here, any shorts in this tube? No. Okay, up above 1300. So we're at 1200 here. So we're going to look for a better tube. So you see what I'm doing? I'm going to keep testing tubes till I get one that's a good one. We need a good one. Okay, more cat video here. There's the other one. You see him in there? Oh my gosh. When I go to reach in there to get a vacuum tube, I come out with a cat. You're going to cause a big problem here. I can see it. You know what I got for you guys? I've got the best cat toy going. Look at this. I got this. Look at this. These are among the best cat toys going. You put this on your floor and step on it, it just goes flat. So it's not a problem. And the cats love them. So they don't know I have this here yet. Hey cats. Look what I got. Okay, I'm going to throw this. Okay, you saw where the cats are. Here we go. Ready? Ready? Oh shoot, it didn't go down the hall. I got another one. I threw it wrong. Down the hall. Ready? Hey! Psst. Now he's done, he's picked it up and he's taking it to a play zone. Meanwhile, my other cat's getting ready to electrocute himself by chewing on... Oh my gosh, look what I've done here. You can't look what I've done. No, whoa, 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 off that, get off that. You can't be chewing that. I can't believe he didn't get a shock off that. Oh my gosh, what a mess. Okay, buddy. I think I need some new shop lighting as well. I have some new lights to put in because I've attempted to fix this strip here a number of times, but every time I come in, it's down again. Because of you. Come on. Come on. Don't push this out. What are you doing? Okay, he's going around to the other exit now. Where's he going? Come on out of there. Come on. Look. I got the spring. Oh, he's lost interest. He's on his way anyway. Crazy time in here. Yeah. Here, have a spring. Ooh, a little hissing there. So they're going to play I've Got It, You Can't Have It. Okay, enough of that craziness. I will get back to tube testing. I hope you get a kick out of seeing the cats. I find them, it really is a powerful way to sort of adjust your emotional balance, I would say. Very good. Yeah, I'm going to continue testing tubes and drinking coffee and playing with the cats. Okay, that took a while, but I did find a really good 6AU6. Off the charts, 6AU6. So I've put that in the radio, haven't I? Yes, I have. So this is the limiter for FM. If this makes a difference, it should be quite notable. What am I talking about? I don't know. Okay, here we go. And we're not going. It's because I turned this off. Let's pull that out. Turn this on. There we go. Now, am I still on the... No, I am not. Let's get on the indoor antenna here. That's right, I'm on the outdoor antenna because I was listening to Citizens Band radio. Okay, so we want to go to band number 2. There we are, band number 2. Tuned anywhere down around here. And make sure speakers are connected. Yes. There we go. Come on, anybody. You can't get worse. It's band 2, band 2. Going up and down. Well, this is high on the disappointment list. What did I do now? Maybe running the CB sound through the radio disturbed it so much you can't. Oh, what did I do? I flipped this. Is that a song or is that an advertisement? Why so tinny? Same station.
You don't feel well? Well, there goes every single day that you don't feel well. There's 5 figures that like.
Well.
Okay, so then you're in Seoul and you get a cold or something.
And I get a cold and I just don't go to school and it doesn't impact anyone.
What happened now?
Like,
How could it get so clear?
Like, the stakes are low, and I think that one thing that's just really challenging about, and I don't want to complain about my life. It's amazing, but it is a major pressure on tour of just like this self-obsession with your physical health and making sure that you're
that's
okay
not bad.
so that the show can go on. And if you don't feel like it or you don't feel well, like,
Yeah, a little volume check here.
But you know, when you're just living your life as a student, and you don't go to school,
It's better than it was. That's probably because I aligned the IF. I give a little more juice to the radio that way. But
How does that moment? Because then you have to go. You're back on.
now I'm back, yeah.
You also kick.
I still think the limiter is not working.
All these pressures are still there. It just feels.
You can hear
like
the
you're
hisses.
dealing with them differently.
Yeah, it does feel like I'm dealing with them differently. I think I needed to wipe the slate clean and like approach it in a different way. I think that there were just a lot of growing pains.
So I guess if the limiter were weak and the limit is not being approached anyway, maybe it just wouldn't matter that I put a better tube in there. I guess that's the only way I can rationalize no change happening when I took out what was obviously a very weak tube. Boy. Okay, that's about as far as I can get. I gotta stop. I gotta stop and just think about the situation here. In order to make a good choice of what to try next, I really gotta think this through here. Okay, maybe we'll explore a new opportunity here. And the schematic is loaded with little letters like this: F dash, D dash, J dash. The top of the radio has all kinds of test points on it, which I believe are these. Here they are. You can see some of the test points right here. Just counting them here, there's a lot right around here. So maybe 10, and then down here maybe another 3 or 4, maybe 15 altogether. 15 test points. I looked in the manual I have for the Mark II. What was that? I think it's just the cats. something big happening in my house. I gotta go see what's going on here. Yeah, something weird's going on. Well, I don't know. No idea what the banging was there. Just remain a mystery. So test points, and I'm counting 15, 20 at the most on here. And I look through the manual that I've been using. This is a manual for the Mark II. And there's no reference to these test points at all in the manual for the Mark II. But for the previous version, the 770R, there is a reference to all these points. The problem is the 770R is a little bit of a different radio from this one. How different? I don't know. Probably not very different, but maybe a little bit. The test points may or may not apply. So the first thing I want to resolve is the information that's available, does it really apply to this radio? So let's take a look at the information that's available. Okay, so we're looking at the manual for the 77R, not the Mark II. And I just noticed, interesting, sole manufacturer, Stranton and Company, Birmingham. Cables, Stratenoid. Here we are. This is the information that I'm interested in. Thank you very much for pointing this out to me. Someone sent me an email and said, hey, you must have seen the chart. Well, it made me look harder for it, so here it is. So we have the circuit references here by letters, and they ran out of the alphabet, so they started over again with an A dash, B dash. And let's read this. Voltage values. Figures given below are obtained with the control set as follows. Blah, blah, blah. Muting level fully clockwise. Now they're showing you with two different voltmeters, if you like. One is an actual model, AVO 40 voltmeter, probably very popular at that time, I'm guessing. And just any voltmeter with this kind of internal resistance, 20,000 ohms per volt. And here they've told you what range they're using. The range affects the meter's impedance. So you would have to pick, if you're following this chart, you have to pick a voltmeter with a voltmeter range that relates to 20,000 ohms per volt to get exactly these readings. But you know, the radio is almost as old as me. The radio is maybe older than me. So what are the chances that there's precision in any of this anymore? Probably not all that great. So you see they're giving it to the volt. Yeah, they didn't mention any plus or minus here. Something interesting with these numbers is to compare these two voltmeters. Now they didn't bother telling us what the ohms per volt is over here, even though they told us the range they're using on this test. But just going down, we can just look and compare. You know, one meter says almost 100, the other meter says 80. So this is a lesson for anybody doing this work. Look at one meter says 212, the other one says 84. This is almost certainly the better meter, so I think this is less than 20,000 ohms per volt. So these are dramatically different readings. Like if you're expecting 33 and on your meter shows 24, I think you'd say, well, something's wrong here. And this 33 is pulled down from the real voltage, which is probably 35 or 37. Who knows? Look at this one, 96 versus 66. 4 versus 2, that's half. So so it's very important that you use the same type of meter that was used to obtain these numbers if you want to obtain the same numbers. Now I've got a vacuum tube voltmeter, beats this. It's better yet. So I would expect all my voltage readings done with it to be higher than this number. Same or higher, except the age factor in here. Okay. 0.4? You can really measure 0.4? Now, look at the number of spots here. This is an alphabet plus almost another alphabet. That's like 50, almost, or say 40 points. But I've only got 15 points visible on top of this radio. So some of these points must just be spots in the circuit. There is no diagram showing the test points on the top, which is really upsetting because they put the test points on the top to make something easy. And those are probably powerful test points in the sense that they're probably very, very important. But nowhere is there anywhere where they tell you where the, test point A is here, test point B is there. Except on the schematic, which you can't relate to the chassis with a vast amount of effort. So I don't get it. I don't get it. I have the test point information, but I don't know if I can really avail myself of it at all. It's from a slightly different radio. And yeah. Well, I'm going to leave it right there for the moment and go drink some coffee because I think this is just not going to get me anywhere, unfortunately. I get such valuable information. Some radios, I wish they'd done that with this one. What they give you are tube pin resistances. So with the radio switched off, you pull the tube out and you're told what resistance to expect to the chassis in each one of the tube spots. My Hammerland SP600 has that kind of information, and it is really powerful for tracking down problems. But it's not here. Test points I can't test. Yeah, I gotta stop and think more about this now. It takes time for ideas to develop, so here's my idea. I found a 6AU6 in the radio that I had tested previously, that I tested today, and found it to be very, very weak. There's a number of 6AU6s in this radio. I tested them all. Maybe there's more weak ones, and there was something wrong with my testing method for 6AU6s when I did it. Because what I do is I set up the tube tester for that kind of tube, and then I do all the 6AU6s because it's easy, because the tube tester is already set up. But if it was set up wrong and bad tubes were testing good, then there may be more bad 6AU6s in here. The only way I can know is to test them. And how many are there? There aren't really that many, are there? Let's see here. So 1, that's the one I already did today. 2, 3. So there's 2 more. One is S meter on AM, tuning indicator on FM. And that's not too. Another one is 6AU6 noise amplifier muting. Both of those seem to be like off to the side of the kind of problems I'm having, but nevertheless I need to do this. So 2 more 6AU6 is going to get tested, and we'll see what happens. Okay, this one drives the S meter and tuning indicator for FM. So the meter's not working right. I just assumed it was a low signal. Maybe it's this too. So okay, shorts. Nope. And the test again is supposed to come up to 1300 up above my finger here. That's a beauty. Okay, can't be a problem with that. I gotta wonder how I missed the other tube, or did it fail subsequent to putting it in the radio and operating the radio. It's not very likely, but I don't know how else to explain it. Okay, next tube. Here, let me get it ready here. I have noticed, pulling all the tubes out of the radio and looking at them, there's quite a mixture of manufacturers, and that kind of suggests that this radio's been serviced quite a few times, and tubes have been changed quite a few times. Okay, because I imagine that when they first built it, all the tubes, or nearly all the tubes, came from the same manufacturer. Now, maybe that's not really the case. Here we go. Any shorts in this guy? No. She's a beauty. Okay, so I got 3 good 686s in there. What's happening, man? What is happening? Well, let's see. It's 11:15 in the morning here, I think. Yeah. What to do here? What to do? So I'm continuing to try to avoid taking on invasive operations here, like changing parts. So I'm looking for every possible easy thing, because I'm telling you, there's nothing worse than doing a whole pile of risky work on a radio and then finding out, oh, it was this all along. You know, I don't want that to happen. Especially with something like this. If I go in and start, get my soldering iron out, it's a bit of a downhill journey for the radio, I'm sure. Even if I replace the parts successfully in that, I don't think the radio will be as good as it could be. And it is full of, I guess, questionable capacitors. It could be there is no simple solution here at all. But at least I should be able to pinpoint the problem. That would be great, and maybe zero in on one component or 2 components that are causing the problems. That's really what I'd be happy with if that happened. But that hasn't happened, because I still don't know what's going on here in terms of distortion coming out of the output. Still haven't tested these 2 tubes. Did feed an audio signal, a sine wave, through the audio amp. Sounded fine. Sine wave may not reveal too much. So conceivably audio circuits are fine based on the tests I've done. Detector tube's been changed a couple times now. AM side seems to work. I was listening to CB this morning, but the volume has to be cranked right up. So the output power of the audio circuits here, it could be it's just low, and even though tubes are good and stuff like that, the output is still low. Could be because of this transformer. I don't know who did it. It's a nice job. Somebody did a nice job on it, but how do I know that this isn't really the cause of all the distortion? Because I've listened to the signal earlier on in the radio and it's still hear the distortion. That's how you know. The test point thing is very disappointing. Yeah. The test point information that I have available, I would have to reason out the location within the radio by studying the schematic and then finding the spot inside the radio that is the same as the test point they're quoting, and then I could test the voltage there. That's a lot of work. I mean, it'd be great if it was like this, but it's not. So that's a hard road to go down too, and it's non-invasive, just taking voltage readings. But again, if I could localize or even pinpoint the trouble, to do that I have to listen to the signal coming through the radio and detect when the distortion starts. Maybe that's it. Maybe I got to do that. I've listened to it way out here. It seems to be distortion free in the sense that if I feed in a sine wave, it sounds okay coming out. I've gone through the IF, and although the kind of distortion we're hearing, I don't know if it can happen in the RF circuits. So that would just leave it right in the detector zone. I could argue that the problem is already localized to the detectors. AM detector sounded okay, but we're listening to CB. That's not a very good signal source, but weak. The FM sounds distorted. The two are different detectors, completely different detectors in the radio. So if I think I should focus on the FM detector somehow. Okay, now that's what I'll think about. I'll think about what can I do about the FM detector in here, aside from the alignment I did. Maybe there's some test point voltages in that area that I can sort out and look for proper voltages. I don't know. I'm gonna spend my day thinking about that. Tomorrow we will attack the FM detector. Attack. Thanks a lot for watching, and keep hope alive.